सॉल्व कर पाए आप में से कोई? हेलो, could you solve? Can you hear me?
Yes, sir.
Yes, sir.
Okay. So could anyone solve it? Okay, one important information about this problem. See, when we talked about the turbine part, because it's a gas turbine, okay, it's a turbine. When we discussed about the turbine and we applied the steady flow energy equation to a turbine, we said that the value of QCV is equal to 0. We also said that the changes in kinetic energy that is equal to 0. We also said that the changes in potential energy that is also equal to 0. But in this particular problem, we have been given with the values of all these three parameters. So we will have to start from the scratch actually. Matlab from the starting actually we will have to do this numerical problem. So let us see. There I have given the data of the question. So the mass flow rate of the air is 20 kgs per second. Inlet pressure to the turbine here it is 7 bar, temperature is 500 Kelvin, velocity is 5 meter per second, and the elevation here is 6 meters, whereas the elevation at the exit is 2 meters. Pressure is 1.2 bar, temperature 300 kilopascal, velocity 7 meter per second, and the elevation 2 meter. And we have to calculate what is the value of the power. There is a dot over WCV. It means we have to calculate the value of power. Okay. And one more thing which is given to us is that the heat loss from the system is at the rate of 5 kilowatts. So this much amount of the heat is continuously going out. When we actually theoretically analyze the concept, we said it's a insulated boundary, insulated control volume. So no heat loss will take place from the system to the surrounding or from the surrounding to the system. In an actual system, it can never happen. Whether you have perfect insulation also. However, the perfect insulation you may have, but there will be some heat loss. Okay, so we have this data which is given to us. So let us now, before this, first of all, I would like to write the steady flow energy equation, and that is given by Q dot CV minus W dot CV is equal to M dot HE. For exit, we are using 2, so I am writing it here as 2 minus H1 plus V2 square minus V1 square by 2 plus GZ2 minus Z1. So this is the equation which we have to use. Let us try to see what is given to us and what we have to calculate. This is already known to us. So QCV is known to me. WCV, this is unknown. We have to calculate it. Mass flow rate is known to me. Okay. This velocity is known to me. This velocity is known to me. Z is known to me. G is known to me. Only unknown parameter that I do have is H2 minus H1. This is not known to me. And you know that H is equal to, you can say U plus PV. Okay, U plus PV. So that means we have to calculate H from this equation first of all. Okay, this is one way of doing it. So that means I need to calculate the value of U1. I should have the value of P1. I should have the value of specific volume V1. So first of all, what I will do, because air can be considered as a pure gas or perfect gas, so I can use this particular equation. PV is equal to MRT. And if I divide both sides by M here, M and M cancels out, and this V by M becomes specific volume. So I am writing it as specific volume. And here in this expression for H, this is specific volume. Okay, so I can say that V1 is equal to RT1 by P1. Now for air, I have already told you, you should remember the values of Cp, Cv and R. Okay. So Cp is equal to 1.005 kilojoule per kg Kelvin. Cv is equal to 0.718, same units. And then R is the difference of these two, and the value is 0.287 kilojoule per kg Kelvin. So this is the value of R. So I can put this value as of R, then this is the value of temperature, and this is the value of P1. So this is in kilopascal, this is in Kelvin, and the unit is known to you. And when we will calculate, this value of V1 comes out to be 0.025 meter cubes per kg. In a similar manner, what I can do is I can calculate the value of V2. So I have calculated the value of V2 here. It comes out to be 0.7175 meter cubes per kg. And then I can calculate the value of H1, which is equal to U1 plus P1 V1. Okay, this I will explain you later on, this part. And if I want to calculate the value of H2 minus H1, it would be equal to U2 minus U1 plus P2 V2 minus P1 V1. Okay, this also once again later on we will discuss about it. So U2 minus U1 is equal to CV T2 minus T1. Okay, and P2 I know it is equal to, you can see it from here, it is equal to 1.2 bar. You can change it into kilopascal, so you have to multiply by 10 raised to power 2 and 1.2 into 10 raised to power 2 kilopascals. So you can see it here. Pressure, this is the volume of value of specific volume, this value you put it here. Similarly 700 kilopascal is the pressure at inlet, this is specific volume. And CV we have calculated, this is T2, this is T1. So the answer of H2 minus H1 comes out to be 201 kilojoules per kg. So this is the answer. Now see, this is one way of calculating the value of the enthalpy difference. Other way could have been very simple. I can use H2 minus H1 is equal to Cp T2 minus T1 and then forward. Sometimes in the numerical problem, if it's not air, then you may have to use this particular equation, H is equal to U plus P1 V1 or H is equal to U plus PV. But suppose you are not given with the values of specific heat, and if it is not air, it is carbon dioxide, you may not be knowing the value of Cp in that particular case. Okay, and you are given with the value of Cv only, or with the value of R, or there is, if there is some situation where you don't calculate, you can't calculate the value of H2 minus H1 directly, then you can follow this particular procedure using the H is equal to U plus PV. Otherwise you can directly use this particular equation also. So you can see it here. I think I have not done it. So further it's quite simple actually. Okay, it is H2 minus H1. Cp value, you know, T2 minus T1 is already known to you. Just wait a minute, I will show you. Can you see this PDF?
Yes, sir.
Yes,
It's
sir.
visible.
Okay, so you see it here. Next, what I have calculated. See, I won't be able to write it here. I am coming to this particular point. V2 square minus V1 square by 2. It is the change in the kinetic energy. So you just see, I have written it as 7 square minus 5 square divided by 2. And you can see what is the unit of it. It is coming out to mean meter square per second square. Okay, it is meter square per second square. But the value should be in kilojoules per kg. So what I have done, I have multiplied this value by kg and divided by kg. So what do you get now? You can write it as kg meter per second square into meter per kg. So you can see this is kg meter per second square. This value becomes Newton, and this is meter, and then kg. So it is actually Newton meter is joule. So to get the value in kilojoules, you have to divide this value by 1000. 12 you will have to divide by 1000. So final value of V2 square minus V1 square will come out to be 0.012 kilojoules per kg. This is what you get. Similarly, for potential energy case, this is the value of G, and this is the value of Z2 minus Z1. And once again, the value comes out to be in joules per kg. So divided by 1000, and the final value comes out to in kilojoules per kg. And then finally, you can put all the values here, and the final answer comes out to be this one or this one. This is 4022.61 kilowatts. And if you want to calculate it in megawatt, you will have to divide this particular value by 1000. Here you divide by 1000. Okay. And this is the final answer in megawatts. Okay. So any questions? Any questions?